guys, welcome back to my YouTube channel. So today we are going to solve day 20 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2415, reverse odd levels of binary tree. Okay, so let's read the problem statement first. Given the root of a perfect binary tree, okay, we have to reverse the node values at each odd level of the tree. Okay, for example, suppose the node values at level 3 odd. Okay, this is nothing but odd level. Okay, these are the values, right? Node values. Then it should be become this one. Okay, 18, then 29, then 11, then 7. Okay, then 4, then 3, then 1, and then 2. Okay, so this is what we need to do, right? We have to reverse the node values at each odd level of the tree. In the end, we have to turn the root of the reversed tree. Okay, question statement is very easy, right? It's very easy to understand, right? A binary tree is perfect if all parent nodes have two children and all leaves are on the same level. Okay, the level of a node is the number of edges among the path between it and the root node. Okay, so let's go over the example number 1. Okay, so this is tree given to us. Okay, so this is I can say that this is level 0. Okay, this is level 1. Okay, so this is odd level. Okay, this is odd level. Okay, and this is level 2. All right, this is even level. Okay, so only one odd level is there. So here what we are doing, we are reversing it. Okay, so 3 5. Okay, and here if you read it, it is 5 3. Okay, so we just reverse it. Okay, so here we reverse these two values. Okay, in the end, so here I'm writing 2 5 3 and then everything else same, right? So the tree has only one odd level. The node at level 1 are 3 and 5 respectively, which are reversed and become 5 3. All right, so now I'm going to solve this problem using two approaches. Okay, first I'm going to solve this problem using BFS. Okay, and then I'm going to solve this problem using DFS. Okay, so let's start with BFS first. Okay, so let's say I have this tree. Okay, so this is my root node. Okay, 1, and 1 has two children. Okay, 2 and 3. Okay, and then this 2 has two children. Okay, let's say 4 and 5. All right, and this 3 has two children, 6 and 7. Okay, and then after that, let's say this 4 has two children. Let me just name them as 8 and 9. Okay, so let's take some bigger example. Okay, only then you guys will get better understanding. Okay, this is very small. Okay, 8 9 and 10 11. All right, and here 12 13. Okay, and here for this one, let's say 14 and 15. Okay, so now what we need to do. Okay, so here this is nothing but my level 0. Okay, this is my level 1 odd level. Okay, this is odd level. This is level 2 even level, and this is my level 3. Okay, so I'm going to use simple BFS now. Okay, so here what I'm going to do, first I'm going to check if my root is equal to null, then return null, but root is not equal to null. So okay, in this case, now after that I'm just going to take one queue. Okay, so I'm going to create one queue. Okay, so let's say this is my queue. Okay, this is my queue. All right, so in this queue, first of all, I'm going to add my root. Okay, so my root is this one. Okay, so in the queue I'm adding this one. All right, I have it this. Okay, then initially I'm going to take my level as 0. Okay, so level value is 0. All right, and now I'm going to run one while loop, and inside the while loop I'm going to check one condition while my queue is not empty. So right now my queue is not empty. Okay, and what is the size of my queue? The size of my queue is 1. Okay, size, this is nothing but size of my queue. All right, then after that I'm going to create one array list of current level nodes. Okay, current level nodes. So I'm going to create a array list. Okay, so let's name this array list as current level nodes. Okay, now here I'm going to iterate over all the elements in my queue, okay, all the elements in my queue, okay, I'm going to poll this element first, okay. So let's say I remove this one from my queue, okay. So this one comes outside, okay, this one comes outside, okay. Now here I'm going to add this one in my current level nodes, okay. I'm going to add this one in my current level nodes, okay, current level nodes, okay. I'm adding this one here, all right. Then here for this one, what are the different childrens, okay. So for this one, this 2 is the children and this 3 is the children, okay. So I'm going to add this 2 and 3 in the queue, okay. I have added this 2 and I have added this 3 in the queue, okay, clear. Now here level is still 0, okay, level is still 0, okay. So this level is even now, this level is even, right? So I'm not going to do anything here in my current level nodes, okay. Now after that I'm going to increment my level to +1, okay. So now my level becomes 1, okay. So now I move to this level, all right, to this level, all right. So now in this level, okay, I'm in this level, okay. So here remove this. Now I'm talking about the next level, okay. So here first of all poll the elements, okay. First of all this 2 is there, okay, and 3 is there, okay. So here one by one we have to remove the elements. So first let's say I remove this 2, okay. So I remove this 2 out of queue, okay. So this 2 comes outside, okay. Now for this 2, what are the different childrens, okay. So first of all add this 2 here as well, okay, current level nodes. I added this 2, okay. And for this 2, what are the childrens? 4 and 5, okay. So I'm going to add 4 and 5 in my queue. I've added this 4, I've added this 5 in the queue, okay. And then after that I poll this element 3, okay, poll this element 3, all right. I've added this 3 here, my current level nodes, and for this 3 I'm going to add the children, which is nothing but 6 and 7, 6 and 7, okay. This is done. So I have processed all the elements for this level, okay, 2 and 3. So these are the nodes, okay, 2 and 3. So I have added this 2 and 3 here, and I have processed all the children of 2 and 3, okay. 4 5 6 7, I have added them in the queue. That's it, okay. I have processed all the elements, okay. So now my current level is 1, current level is 1, okay, current level is 1. So this is nothing but, this level is nothing but my odd level, right, my odd level. So now what I'm going to do, okay, so this is nothing but my odd level. So if in this case I'm going to iterate over all these elements in my current level nodes, okay. So I'm going to take one pointer, okay. So let's say this is my left and this is my right, okay. Left and right pointer I'm going to take if my level is odd, okay. So if my level is odd, I'm taking the current pointer, and what I'm going to do here, I'm going to take, I'm going to run one while loop while my left is less than right, okay. So now as of now left is less than right, okay. So here I'm going to create one temp variable, and in the temp variable I'm going to store the value of this left, okay, in my temp. Then after that I'm going to update the left value, which is 2, okay. As of now I'm going to update it with 3, okay, this value 3. And then I'm going to update the value of right, which was 3, with the temp, which is 2, okay. So this is going to become 3 and this is going to become 2, okay. This is what I need to do, okay. So this is done, okay. So that's what we need to do, okay. So here what I did, I just changed the, I will just swap them, okay. I've just swapped them, okay. This 2 becomes 3, this 3 becomes 2, okay. So once this is done, okay. So here simply means that I'm going to change this to 3, okay. I'm going to change this to 3 and I'm going to change this to 2, okay. So here what I did, I swap the children of this one, okay. So my current levels nodes, okay, dot get left, okay, this one dot value I have changed it with this and this, okay. So this is what I need to do, okay. I have updated it, okay. So this is done, this is done. Then after it I move to the next level, okay, level 2, level 2, which is even, okay. So here I have to process all the children of 4 5 6 and 7, okay. So this is my current level, okay. So let me just remove this. So here first I'm going to process 4, okay. So 4 children is 8 and 9, okay. So let's say I have added this 8 and a 9, Okay, so here I have added 4. Okay, then I'm going to process 5. For 5 children is 10 and 11. Okay, 10 and 11. Okay, so here I have added this 5. Then for 6 I have to process the children, that is 12 and 13. Okay, so I have to add 12 and 13, and I have to add 6 here. Okay, then I have to add 7 here and add the children of 7. Okay, 7 children is 14 and 15. Okay, so here I have added 14 and 15. Okay, let's say I have added 14 and 15. 14 and 15, but since my current level is even, so I'm not going to do anything. Okay, I'm not going to do anything. All right, this is done. Then after that I'm going to move to the my next, this 8 and 9. Okay, so for them there are no childrens. Okay, there are no childrens. 8, 9, 10, 11, 12, 13, 14, there are no childrens. Okay, so my queue will become empty in the end, but I have to process all the elements here. Okay, in my current level nodes, all the values typed is 8, 9, 10, 11, 12, 13, 14 and 15. Okay, these are the different values. Okay, so my level was 3. Okay, when I reach here, so for them there are no children, so here I'm not adding anything. Okay, so now I have to process here. So what I need to do again, take 2 pointers left and right, left starting from here, right starting from here, and while my left is less than equal to left less than right. Okay, so I have to change this 15 with 8. Okay, so here I'm going to change this. See here, this 8 is going to become 15, and this 15 is going to become 8. Okay, this 9 is going to become 14, and this 14 is going to become 9. This 10 is going to become 13, and this 13 is going to become 10. This 11 is going to become 12, and this 12 is going to become 11. Okay, so I have reversed it: 15, 14, 13, 12, 11, 10, 9, 8. Okay, this is what we need to do. Okay, and then we have to come out because my queue is empty. Okay, so in the end I'm just going to return the root. Okay, my what is my root. Okay, that's what we need to do. Okay, so here 1, then 3, 2, 4, 5, 6, 7, then 15, 14, 13, 12, 11, 10, 9, 8. Okay, so this is what we need to do. Okay, this is simple BFS. Okay, simple traversal. We are doing level by level, right? So now let's write the code for this one. Okay, with the code you guys will get much better understanding. Okay, so now here same story that I explained. Okay, if the root is equal to null, all right, then in that case we have to return null. Okay, and then after that take a queue. All right, and here 3 node. Okay, and queue new linked list. Now initially level is 0. Okay, same story whatever I explained, right? Same story I'm going to write here, and here I'm just going to write while my queue is not empty. Okay, and inside this take the size of my queue. Okay, int size is equal to queue dot size. Okay, current level elements we have to process only. Okay, for the current level only we have to add all the childrens, right? And then I'm going to create one array list. Okay, so here list of 3 node current level nodes. Okay, current level nodes. Okay, this is what I'm interchanging. Okay, so this 3 node only I'm interchanging, right? So current level nodes is equal to new array list. Okay, now here we have to process all the nodes at the current level. So for that I'm going to run one for loop. For int I is equal to 0, I is less than size and I plus plus. Okay, and here take node. Okay, current node as q dot poll. All right, and then in the current level nodes I have to add the this particular node. Okay, this particular node only. Okay, and I'm going to add the children in the queue, but in the current level node I have to add just this node, right? So here if node dot left is not equal to null, all right, then in that case just add the element in my queue dot add node dot left. Okay, and here if node dot right is not equal to null, okay, then in that case in the queue just add node dot right. Okay, same story that I have explained, okay, step by step. So this is done here. All right, I have added the elements in the queue. Okay, now here there is one more thing. Okay, so here until here I have added all the elements, okay, in my queue. Okay, this ends here. All right, so now, okay, now after that we have to reverse the node values if the current level is odd. Okay, only then we have to reverse them. So here if level modulus with the 2, okay, is equal to 1, that simply means that it's a odd level. Okay, so in that case take 2 pointers. Okay, 2 pointers approach we are going to take. Left is equal to 0, all right, and I can say that right is going to be current level nodes dot size, all right, -1. Okay, so 2 pointers I took here, right, and then after that I'm going to write while my left is less than right. Okay, until then what I have to do, create one temp variable. Okay, in the temp variable I'm just going to pass the left value. Okay, so here current level nodes dot get the left. Okay, get the left dot val. Okay, this value I took. Okay, now after that I have to update, just copy this. Okay, so in the left we have to put the right value. Okay, so here current level nodes dot get left dot val. Okay, I'm going to update it with current level dot get right dot val. Okay, right dot val. All right, and then here current level dot get right. Okay, now I have to update the right. So right I can update with the temp. Okay, just swapped. Okay, everything is swapped. Okay, temp, that's it. Okay, and then what we are doing, we are just updating my left and right, right minus minus, left plus plus, and right minus minus. Okay, and okay, and here this ends and here this ends. Okay, so here queue is not empty. Okay, so once we process one level, then I have to increment the level as well, right? So here I'm just going to write level plus plus. Okay, this is done, and once this is done, okay, here in the end we have to just return the root, return root. Okay, so now this is what we need to write. Okay, that's all. 35 line support. Let's run it and see if there are code issues. We'll try to fix that. So yes, there is some issues. Okay, all right, so here we missed one thing. Okay, so here in the queue initially we have to add the root as well now. Queue dot add root. Okay, so here one second, if you see the output, okay, so you are getting this simple 235. Okay, same thing. Okay, so you initially you haven't added anything. Okay, so you have to start with adding the root first, right? Now let's run it. Okay, this was the first step. So see, all the test cases has been accepted. Okay, so now let's submit it and see. So see, our solution is accepted, right? And the time complexity for this part is going to be O of n. Okay, since we are just iterating over all the nodes one by one only, right? And in the queue also I'm adding the elements one by one. Okay, so the time complexity for this is going to be of n only. Okay, mainly. So now let's move to the DFS approach. Okay, all right, so now let's move to the DFS approach. Okay, so in DFS approach what we need to do. Okay, so let's take the same example. Okay, so here DFS code is going to be very small. Okay, so here we are going to start from this position. Okay, from this, so this is nothing but my level 0. Okay, level 0. This is nothing but my level 1. Okay, this is nothing but my level 2. Okay, and this is nothing but my level 3. All right, so here DFS. Okay, we are doing the DFS. Okay, so here, from here, okay, I'm just going to call one function. Okay, let's say traverse DFS. Okay, and in this, for this, okay, for this parent I'm passing the two children. Okay, so for this, what are the two children? Okay, so root dot left root dot left is 2 and the root dot right is 3. Okay, and I'm going to pass the level. Okay, current level is 0. Okay, current level is 0. Okay, for this one. All right, so here, this is what I need to do. Now here, we have to change these two. Okay, so here, for this parent, okay, see carefully, for this parent I am adding the two children. Okay, so parent is at even level, parent is at even level. Okay, that is why I'm writing 0, but the children that I'm adding are at odd level. That simply means if my parent is at even level, okay, that simply means that the children are going to be at odd level. Okay, so here what I'm going to do, I'm going to check if level modulus with 2 is equal to 0. Okay, if level modulus with 2 is equal to 0, then I'm going to do the swap. Okay, so this level is of parent, but since I am passing the children in this, okay, since I am passing the children in this, so that is why I have to check for this condition. Okay, if level modulus with 2 is equal to 0. Okay, so in that case, same way, take one temp variable and in the temp variable add the value of the left child value. Okay, then update the left child value with the right child value, and then update the right child value with the temp. Okay, this is what I need to do. Okay, so I am going to call this drivers DFS of 2, 3 and 0. Okay, so here, if I write, so I'm going to write it like this: DFS 2 and 3 comma 0. Okay, so this is going to change 3 2. Okay, this is going to make it to 3 2. Okay, let's say 3 and 2. Okay, change it. All right, then I'm going to call the DFS, okay, for this and this. Okay, so how I'm going to say that: left child dot left and right child dot right. Okay, so here I'm going to call the DFS of 4 and 7. Okay, DFS of 4 and 7 I'm going to call, and from here I'm going to call DFS of 5 and 6. Okay, DFS of 5 and 6, and both are at this 2 and 3. Okay, so at level 1. Okay, so level 1, so here level 1 I'm going to write. Okay, so this is what I'm going to call. So see here, the level, this level is odd. Okay, because of their parents. Okay, because of the parents 2 and 3, but the children are at even level. Okay, children are at even level. Okay, these children 4 5 6 7, 4 5 6 7, these children are at even level. Okay, so we are not going to change anything, we are not going to do anything. Okay, then again for this I'm going to call DFS of left child dot left and right child dot right. Okay, so left child of left, force left, it left is 8. Okay, so here see carefully, DFS of force left child is 8, and what is the right child of right, 7's right child is this 15. Okay, 8 15, and coming from level 2. Okay, coming from level 2. All right, so DFS of 4 is here I called left child of left, okay, and right child of right. Then after that we have to call same way, so this. Okay, now 9 and 14 we have to call. Okay, so DFS left child dot right, so left child dot right and right child dot left. Okay, 9 and 14, 9 and 14 from level 2. Okay, so here 8 15 2. Okay, 8 and 15, and then 9 and 14. Okay, now for 5. Okay, first we have to call left child of left, left child of left and right child of right. Okay, so 10 and 13, DFS of 10 and 13 from level 2. okay, and here I'm going to call DFS of 4 6 okay, for this 5 and 6 same again. So left of right and right of left. Okay, so here it is going to be 11 and 12. Okay, so here I'm going to write DFS of 11 and 12. Okay, and this is nothing but from 2. Okay, so all these are coming from, all these are in odd position. Okay, and here level is 2, okay, which is even. So if my level is even, okay, level modulus 2 is equal to 0, then we have to swap. Okay, so what I'm going to swap, I'm swapping 15 with 18. Okay, 8 and 15 I'm going to swap. So here 15 comes here, then here 8 comes. Okay, swapping what, 9 and 14. Okay, so here 14 will come and here 9 will come. Swapping what, 10 and 13. Okay, so 13 comes here and 10 comes here. Swapping what, 11 and 12. So here 12 will come and here 11 will come. Okay, so this is what we need to do, simple swap. Okay, so code is going to be very very simple. Okay, with code you guys will get much better understanding. Okay, so let's write the code. Code is going to be of, I think, 10-15 lines hardly. Let's see. So reset to default code animation. Okay, confirm. All right. Okay, so let's write the code for this one. Okay, so here what we need to do, 1 second. So here first thing that we need to do here, okay, so call one traverse. Let me just zoom it, traverse DFS. Okay, so here I'm just going to pass it root dot left, root dot right, and initially my level is 0. Okay, this is done. All right, and from here just return the root. Okay, so this traverse DFS is going to make the changes for us. Okay, return root then. All right, now inside this let's write the function. Okay, private void traverse DFS. Okay, and in this I'm just going to pass 3 node left child. Okay, 3 node right child. Okay, and I'm passing level. Okay, int level. All right, and here inside this just check one base condition. If left child is equal to null, okay, or right child is equal to null, okay, then in that case simply return. All right, and now we have to check if the current level is odd. Okay, then we have to swap the values of the children. Okay, so if level modulus with 2 equal to 0, okay, so this level is coming from the parent. Okay, so that's why but this is what I have explained here. Okay, for 1 I'm adding 2 3, but level is 0 because it is coming from this. So but children are at odd level. Okay, that simply means, so this is what I need to check. Okay, so here, so write the same thing but I have explained here, this thing. Okay, t is equal to left child is equal to right child is temp. Okay, so int temp is equal to left child dot val, left child dot val is equal to right child dot val. All right, and then right child dot val is equal to temp. All right, okay, and then we have to again call this traversal method. Okay, so here just copy this line, paste it here. So traversal. Okay, here now instead of what I have told you. Okay, so what we are doing, so here if you see, left child dot left and right child dot right first. Okay, so here left child right left child dot left and right child dot right, and here level plus 1, level plus 1. Okay, so this is what I'm doing right here. Left child, this is my left child now. Left child dot left, right child dot right. Okay, this is one thing. Then left child dot right, right child dot left. Okay, so copy this same thing, paste it here. Okay, so here left child dot right and the right child dot left. Okay, so this is what we need to do. Let's run it and see if there are code issues. I try to fix that. So all the test case has been accepted, right? Now let's submit it. So see, our solution is accepted, right? And the time velocity for this one is also going to be O for n. Okay, so I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.